Okay. Can you see my screen?
Yes,
Yes,
sir.
sir.
Okay, good.
Yes,
Okay. Before we begin with the tutorial, so basically today I plan to discuss the tutorial questions that I have given to you last week. I hope that all of you have tried to solve the problems. But before that, let's look at the um, what we have covered in the first week. Okay, so basically we have learned about the basic kinematics equation. Okay, I hope all of you have watched the videos. Okay, I have shown in the videos that the velocity v is equal to ds over dt. This is a differential equation. Okay, differentiate the displacement with respect to time, ds over dt, and then from the velocity we can then calculate the acceleration. Okay, a is the acceleration, which is equal to dv over dt. Okay, and then we can also rewrite these two equations. The first two equation, v equals to ds over dt and a equals to dv over dt, and we can get the third form of the basic kinematics equation, a ds equals to v dv. So all of these equations are very important in order to derive the constant acceleration. So that there are some cases, ada beberapa keadaan di mana acceleration of the object is constant. Maksudnya throughout the motion, from the beginning until the end, the acceleration of the object is constant, tidak berubah, tetap pada acceleration yang sama. Therefore, we can use three new equations that can be derived from the basic kinematic equations study. So I think all of you should have already watched how these three equations are derived from the videos. Okay, so basically we can rewrite this from the first and the second basic equations into becoming the third equations. Okay, this is basically the three basic kinematic equations, and then we from the second equation here we can derive the first equation in the case where the acceleration is constant. Okay, if the acceleration is constant throughout the motion, then we can calculate the velocity using this equation. Only if the acceleration is constant. Kalau acceleration dia berubah-ubah, kita tak boleh guna these three equations. Tapi yang the first three basic kinematic equations ni boleh gunalah. But only for constant acceleration case, we can use this equation. Ini untuk calculate the velocity. V equals to V naught. V naught ni ialah the initial velocity of the object plus the AC. AC here to indicate the constant acceleration. C dekat bawah tu maksud dia constant lah. Constant acceleration multiplies with T, the time. Okay, and then from equation 1 here, we can do another integration. Okay, I have explained all of this in the video in detail, so you can watch the video if you don't understand. And in the end, we can get the equation to calculate the displacement. Okay, the displacement S is equal to S naught, which is the initial displacement, plus V naught times T, this is the initial velocity. Yang ada 0 kat bawah ni is the initial. Okay, and then plus 1 over 2 AC, the constant acceleration, multiplies with T square. Right, T is the time lah. So this will be the second equation that we can derive from the three basic kinematic equation in the case of constant acceleration. And finally, from the equation number 3, we can derive another relationship, another equation, and in this case, it is the relationship between velocity, acceleration, and the displacement. So there is no time involved in this equation. Okay, so whenever you have a problem, the information given to you is, let's say, for example, the acceleration and the displacement. No time is given in the problem, so you can go to this equation. You can use this equation. Okay, this is v square, which is the velocity square is equal to the initial velocity v naught square plus 2ac, the constant acceleration, multiply with the displacement minus initial displacement, s minus s naught. Okay, so
Answer the
yes,
question.
yes.
Answer in the second equation derivation tu, and yang dia kata S equal to S naught plus VT, that one. Which one is correct? Sama ada S sama dengan S naught plus V naught T plus half A T square ataupun half A T, sebab dekat dalam previous slide yang saya download daripada kalam tu dia tulis A T without A T square. So, and saya nampak saya pakai equation tu without using the T square. So, which one is correct?
Sorry, saya tak faham. Yang dalam kalam saya letak equation ni tak ada square?
Tak ada, sir.
Sekejap saya check. Maybe ada typing mistake dulu. Sekejap Let me check. Oh, okay. You mean dekat sini ada square, but then in here tak ada square maksud you?
Yes, sir.
Okay. This one is wrong. This is my mistake. I will correct this. So this is V naught T plus half AC T square. There should be a square here. Okay, thank you for pointing that out. I will re-upload the slides later. Okay, any more question on the topic that we have covered in the first week? So basically, what you need to know from the last week's lesson is these three basic kinematic equation. Okay, and then from these three we can derive three more equations only for the case where the acceleration is constant. Okay, or only for that case. And then you have to, if you have problem with differentiation and also integration, you have to go back to your mathematics, to calculus, and do some revision lah, because in the first chapter ini kinematics we will use a lot of differentiation and also integration. Okay, because when you want to get the velocity from displacement, you have to do differentiation, and you want to get the acceleration from the velocity, you have to differentiate again. But if you want to go back, let's say the acceleration is given, you want to get the velocity, then you have to integrate the acceleration to get the velocity. Okay, so any more question on this before we go to the tutorial?
No, sir.
Okay, yang lain ada soalan?
No, Doktor.
Okay. Kalau ada soalan boleh tanya, nak tanya dalam bahasa Melayu boleh, bahasa Inggeris boleh. Okay, tak ada soalan If you have questions later, kalau you tengok video you have any question you don't understand, you can also write in the WhatsApp group. I will try my best to answer lah. Okay, so let me stop sharing this first and I will share tutorial number 1. I hope all of you have tried to answer. Okay. Okay, let's discuss the tutorial. So we have, I have given you, I think, 7 questions on particle kinematics continuous motion. Okay, so apa maksud continuous motion is whatever that is described in the problem that is the motion of the object from the beginning until the end of the motion lah. So maksudnya pergerakan objek tersebut daripada awal sampai habis, it is the same character, the same characteristics, the velocity, the acceleration is the same throughout the motion. In the next subtopic, where I have also given you the video, which is called erratic motion, that is the difference is the motion is divided into stages ataupun into phases. Ada beberapa fasa. So in the first phase, the motion is different from the second phase, and also it's different from the third phase, for example, if there are 3 phases lah. So that is the difference between continuous motion and erratic motion. Erratic ni dia berubah-ubah dalam tempoh masa pergerakan tu, the motion is changing, whereby the continuous motion is the motion tu consistent daripada awal sampai habis, it moves with the same characteristic of the motion lah. So that is the difference. Alright, now let's go to the tutorial 1 where we discuss about continuous motion. Okay, let's look at question number 1. Okay, if S is 2t to the power of 3 meter, so this is the displacement given, where t is in seconds, determine v when t is equal to 2 seconds. Alright, in this problem, is this a constant acceleration problem ataupun bukan constant acceleration problem?
Bukan.
Bukan, because it is it's not mentioned in the problem yang acceleration is constant. So you cannot use the 3 equations for constant acceleration lah. So how do you solve this? How do you solve this? Anyone want to want to volunteer to give me what is the first step that should we do?
Pakai formula V sama dengan ds per dt.
Okay, good. So siapa tadi yang jawab tadi?
Saya, Firzana.
Okay, Firzana. Okay, very good. Thank you, Firzana. Okay, so kita nak dapatkan velocity. So kita tahu the relationship between velocity and displacement. Displacement is given here. So V equals to ds over dt. Okay, now you need to differentiate lah. S is 2t to the power of 3. 2t cube. So macam mana kita differentiate 2t kuasa 3 ni? ds over dt. How when you differentiate 2t kuasa 3, what do you get?
6t kuasa 2.
60 square. Very good. So V is equal to 60 square. Okay. So now it is very straightforward lah. This will be the function of displacement. Now V, kita dah dapat function dia. V function of V is 60 square. Now dia nak tahu when t equals to 2 seconds. So what you will have to do is to key in the 2 seconds here in the equation here lah, in the function. So you will get at t equals to 2 seconds, V is 24 meter per second. So 6 kali 2 kuasa 2. So 6 kali 4, 24 meter per second. Okay. The unit for velocity is meter per second. Okay, semua dapat jawapan yang sama?
Dapat, sir.
Dapat,
Okay.
betul.
Alright, good. Let's move to question number 2. Okay. Now dia bagi velocity. If V equals to 4t plus 5 meter per second, t is in seconds, determine A. Okay, now we want to determine what is the acceleration when t equals to 2 seconds. So again, it does not mention in the problem that acceleration is constant. So kita tak boleh assume yang acceleration tu constant lah. So we have to use the 3 basic kinematics equation. So how do we solve this? Any volunteer? How do you solve this?
Gunakan formula A sama dengan dv over dt.
Okay, good. A equals to dV over dt. Okay, ini formula dia because V is given, kita nak cari A, so A equals to dV over dt. This time also you have to differentiate. Okay, so now kita gantikan V dekat sini dengan 4t plus 5. So differentiate 4t plus 5, what will you get?
4.
4. Okay, T akan hilang. T akan hilang. 5 ni tak ada variable, so dia akan hilang juga. So what we have is A equals to 4. So which means here is regardless of time lah, A ni tak ada, dia function dia tak ada kaitan dengan masa. Jadi ini menunjukkan the motion of this particle is constant lah throughout the motion. So we have A equals to 4 meter per second. Tak kira lah T sama dengan 1 ke, T sama dengan 2, T sama dengan 3. A dia constant pada 4 meter per second square. Okay, so this is the unit untuk acceleration meter per second square. Okay. Let's go to question number 3. Okay, if A is 2 meter per second square constant. Okay, now the question mentioned that A is constant. Determine V when T equals to 2 seconds if V sama dengan 0 when T equals to 0. So ini kita panggil sebagai initial condition. Dia akan bagi normally in the question, in some questions the initial condition is given. So dia kata bila T sama dengan 0, V sama dengan 0. Maksudnya initially the object is not moving lah. Okay, and then dia mula accelerate, dia mula memecut. So we want to know what is the velocity when T equals to 2 seconds. So how do we solve this? Anyone? How do we solve this problem? You can use the constant acceleration equation here. Okay, Fizana.
Pakai formula V sama dengan V dot plus AC darab T.
Okay. Kita nak V, determine V. So we can use V equals to V naught plus ACT. Okay, V naught here, V naught ni lah kita panggil sebagai initial condition dekat sini. V naught ni initial condition. So kita tahu when T equals to 0, V naught is 0. Okay, then what we do is kita gantikanlah all the all the values given. So kita ada V naught equals to 0 plus AC is 2 and time yang kita nak ialah T equals to 2 seconds. So you ganti juga T dengan 2 seconds here. So we get V at T equals to 2 seconds is 4 meter per second. Okay. Semua dapat jawapan yang sama?
Dapat, sir.
Dapat.
Okay.
Dapat, sir.
Alright. Let's move to question number 4. If A is 2 meter per second square constant, again, determine V when S is 4 meter if V equals to 3 meter per second when S equals to 0. Okay, yang belakang ni tadi saya dah bagi tahu is the initial condition. Okay, dia bagi tahu initial condition bila S equals to 0, V sama dengan 3. Okay, V does not start from 0, dia memang dah ada value daripada awal. Okay, and then the relationship given here is A, V and S. So tak ada time mentioned in the problem. So which equation that we can use in this problem? Anyone?
V square equals to V square naught plus 2AC bracket S minus S naught.
Alright, great. Thank you, Mutu Selvam. So you can use this equation. Yang mana tadi saya dah bagi tahu the third equation for constant acceleration tadi, when you have a relationship yang tak involve time. There is no time given in the problem, so you can use this. V square equals to V naught square, yang ni the initial condition, plus 2AC S minus S naught. Okay, then you gantikan all the values lah. Okay, so what you get? V square is equal to V naught is given here as 3 meter when 3 meter per second when S equals to 0. So ini dia punya initial condition. So here will be 3 square plus 2 constant acceleration AC is also 2. And then kita nak tahu determine V when S equals to 4. So S here will be 4. S not here is this one, 0, the initial condition. Okay, so what you get is V square equals to 25. And then you have to square root to get the V. You have to perform a square root calculation. And you will get V equals to 5 meter per second. Okay. Ada apa-apa soalan? So far, do you have any question? Ada yang tak faham?
No, Doctor.
Okay, semua boleh faham? Alright. Let's go to question number 5. Okay. So, if A equals to S. Ini dia punya function lah. A sama dengan S, meter per second square. Where S is in meter, determine V when S equals to 5 meter if V equals to 0 at S equals to 4 meter. Okay. Yang ini dia tak ada bagi tahu, that S is constant. Okay, so daripada function ni pun kita dah tahu dah S ni tak constant. So because S equals to S. So kalau S sama dengan kosong, A kosong. S sama dengan 1, bila dia dah bergerak 1 meter, A akan jadi 1 meter. So nampak dia memang dah tak constant lah. So from the question itself, you know that the acceleration is not constant. So you cannot use 3 equations for constant acceleration tadilah. So what's left to use is the 3 basic kinematic equations. Okay. How do you solve this?
A ds equals to V dV.
A ds equals to V dV. Okay. Right. So we have the third basic equation, A ds equals to V dV. Okay. And then what do we do with this? Integrate. Okay. So now A here, you can substitute with dia punya function lah. So you can replace S in here because A sama dengan S kan, diberi dalam soalan. So you will do integration for the left hand side is from S1 until S2. Okay, apa S1, apa S2 ni nanti kita tengok. On the right hand side, bila you integrate left hand side, you have to do the same for the right hand side. So when you integrate left hand side, ds, you do the integration also on the right hand side, but on the right hand side you have dv. Jadi the integration will be with respect to the velocity lah. And then here initial condition diberi v sama dengan kosong. So this will be the lower limit of the integration. So dekat bawah ni 0. Nak integrate sampai berapa? Sampai v lah, because sekarang kita nak tahu what is the value of v. This is the one that we want to find. So V here, you just write in V for the upper limit of the integration. Okay. Untuk left hand side ni, we substitute the variable S in A here. So you get S ds. Dia punya lower and upper limit. Lower limit comes from the initial condition here. So it is given S equals to 4 meter. So you put 4 down here, the lower limit. Nak integrate sampai berapa? Sampai dia bagi tahu determine V when S sama dengan 5. So 5 meter here will be the upper limit of the integration. Okay, on the right hand side tadi samalah V dV from 0 to V. Okay, when you integrate S ds, what do you get? What do you get when you integrate S ds?
S square over 2.
S square over 2. Okay. And what do you get when you integrate V dV?
V square over 2.
V square over 2. Okay, samalah. Alright, so what you get is, oh sorry, this is, okay, this is wrong. Saya ada buat silap kat sini. This should be S square over 2. S square over 2 and V square over 2. Okay, I will correct this later. So, and then you will key in the value lah. So 5, this should be s square over 2 and this should be v square over 2. So my answer here should be wrong, I think, but then I will correct later. Okay, and then what you have is here should be 5 square over 2 minus 4 square over 2 equal to v square over 2. Okay, here should be v square over 2. Kat sini pun 5 square over 2, 4 square over 2. Okay, this is my mistake. Okay, and then you should get v equals to 3 meter per second. I will recheck this. This may be wrong also because I forget to put over 2 here. Okay, so integration you should be s square over 2 for this one. Okay, so this is how you solve this question when it involves integration lah. All right, let's go to question number 6. If A is 8t square, okay, now the relationship, the function of A is given in t. Tadi is given in s, now is given in t. Determine v when t equals to 1 seconds if the initial condition is given here, v equals to 0 at t equals to 0. Okay, so ini pun sama macam the previous question, where we have A equals to dv over dt, because what we want here is to determine the velocity. So we have to rearrange this equation. Okay, you bring dt to the left hand side, dia akan jadi A dt equals to dv. Okay, A dt equals to dv, and then we can do the integration, because when we integrate dv, we will get v. Okay, so we have to do integration on both sides. Integrate dv. Lower limit comes from the initial condition here, v equals to 0 until v, because this value v is what we want to find out, determine v. And for the acceleration, it's a dt. So integration, lower limit comes from the initial condition given, t equals to 0, and the upper limit here is here when t equals to 1. So this is what we want to find out. What is the velocity when t equals to 1? So this will be the upper limit of the integration. Okay, so when you integrate nothing dv, you will get v. Okay, on the left hand side you will get v. On the right hand side, you substitute a here with the function lah, 8t square. Okay, so integration of 8t square, you will get 8t to the power of 3 divided by 3. 8t to the power of 3 divided by 3 from 0 to 1. Okay, semua orang tahu kan how to solve the integration. When you integrate, so basically you will substitute the upper limit in t here. So you akan dapat 8 times 1 to the power of 3 divided by 3 minus you substitute the lower limit in the function here. So 8 times 0 to the power of 3 divided by 3. So basically equals to 0 lah. For the lower limit equals to 0. For upper limit, it becomes 8 times 1 to the power of 3 sama dengan 8 lah divided by 3. So you will get 8 over 3. 8 over 3 is basically is equal to 2.667 meter per second. Semua dapat jawapan sama tak macam saya?
Dapat.
Yes, sir.
Dapat sir.
Okay.
Sir, sorry
Yes.
sir, nak tanya kalau kita tak buat yang second tu kan, yang T kuasa 3 tu kita tak buat tu boleh tak? Kita terus buat jawapan.
Macam mana saya tak faham.
Kan kena buat integration kan?
Aha.
Kalau kita tak settlekan integration, kita terus kasih jawapan boleh tak?
Maksud you jawab v sama dengan 8t to the power of 3 divided by 3 macam tu?
Lepas tu terus dapat 2.667.
You dapat 2.67 tu dengan you gantikan T sama dengan 1 lah kan?
Gantikan. Boleh ke sir?
Boleh je. Boleh.
Okay sir.
Okay. Ada apa-apa soalan so far? Before we move to the last question for the tutorial.
Tak ada doktor.
Okay. So kalau tak ada, let's go to the last question. Last question ni panjang sikit calculation dia. Okay. Ada yang dah buat yang ni? Ada yang dah siapkan? Question number 7.
Dah, sir.
Dah, okay. So let's check whether your answer is correct or not. Okay, let's read the question first. A ball A is thrown vertically upwards. Okay, so kita kena, when you read the problem, you have to understand the question first. So ada satu bola A throw upwards, okay, dibaling ke atas from the top of 30-meter high building. So the ball is thrown dibaling ke atas di atas bangunan yang tingginya 30 meter with initial velocity of 5 meter per second. So when the ball was thrown up, the velocity of the ball is 5 meter per second. At the same instant, there is another ball B thrown upwards juga, dibaling ke atas juga from the ground. Tadi daripada atas bangunan, 30 meter punya bangunan, you throw the ball up at 5 meter per second, and then there's another person on the ground also throw the ball upwards, also throw another ball B upwards, baling bola B ke atas, and with a faster velocity of 20 meter per second. So what we want to find is determine the height from the ground at which both ball dia berselisih, they pass each other. Maksudnya ball A is thrown up and then it will go down, and ball B is thrown up. So masa bola A jatuh ke bawah, bola B sedang naik. So dekat mana dia akan berselisih with each other. So that is what we want to find out. What is the height from the ground at which both balls will pass? Okay, boleh faham? Semua faham tak dia punya soalan?
Faham, sir.
Okay, ada yang tak faham soalan tak? Okay, I assume that you have understood the question lah. Okay, my question is this a problem involving constant acceleration or not?
Constant acceleration.
Why do you say it's constant acceleration? Sebab it does not mention in the problem yang acceleration dia constant.
Because of gravity.
Great. Betul, Mutu Selvam. Because of the gravity. So what is the gravitational acceleration? Siapa tahu?
Negative 9.81.
9.81, betul. Okay, so although yang dalam case ni tak ada mention about constant acceleration, but this problem falls under free fall. Kita panggil ini free fall punya problem. So in free fall, we have a constant acceleration of negative 9.81 meter per second square, and this is called the gravitational acceleration. When you release any object on Earth, the object will fall down with this acceleration, negative 9.81, because of the gravitational force. Okay, so let's first visualize the problem. So we have a ball A on a 30-meter high building. Let's say this is a building lah, ball A. So ball A is thrown upwards 5 meter per second. Dia dibaling ke atas dengan 5 meter per second velocity. So what happens to ball A? It will go up and then it will start to move downwards. Okay, dia move downwards ni with this acceleration lah, with the gravitational acceleration of negative 9.81 meter per second square. And then there's ball B on the ground is being thrown upwards with velocity of 20 meter per second. So because of this velocity, ball B will move up. Okay, now what we want to find is what is the point that these two balls pass each other ataupun berselisih with each other. Alright. So to calculate, let's set in my case you can set another origin. We need an origin because this involves displacement of the object. So we need to know which one is negative, which one is positive. So in this case, in my calculation, I set the building as the origin. So point A, where the ball A is being thrown up, will be the origin. Therefore, kita akan calculate the displacement of the ball A ni with respect to the origin lah. So this will be going down from the origin. So bila origin dia dekat sini, the displacement is going down. So S here will be negative lah. Boleh faham tak? So if you set the origin down here, then the displacement will be positive sebab dia naik ke atas. Dalam kes saya ni, saya setkan origin as on this building here. So this will be, the displacement will be going down. So it will be negative displacement. Okay. So first, what we want to find? We want to find the height. The height ni as lah the displacement. And we have established, or we have defined that this is a constant acceleration problem because of the gravitational acceleration. So we can use three constant acceleration equation. So which equation should we choose? We should choose the equation that involve the displacement lah, because what we want to find is the displacement. Okay, so what we have? We have S equals to S naught plus V naught T plus 1/2 AC T square. Okay, AC dekat sini is the gravitational acceleration. Okay, now let's substitute all the values. For ball A, let's calculate ball A first. S here will be, kita dah cakap tadi, S here dekat sini. Starting from the origin, going down. So it will be negative S. It will be negative S. S naught, bila kita set the origin here, so initially the displacement is 0 lah. S naught will be 0. Okay, plus V naught. What is the initial velocity of the ball? The initial velocity given here 5 meter per second. So you put in 5t. Time kita tak tahu. Bila masa dia sampai dekat sini, kita tak tahu the time. So from this equation, we can find the time first. Plus 1/2 AC. I have mentioned earlier, AC here is the gravitational acceleration. So you will substitute AC here with minus 9.81. Okay, kenapa minus? Because gravitational acceleration tu dia going downwards. Okay, going downwards. So secara general kita ambil sebagai whatever is going up is positive, going down will be negative. So gravitational acceleration ni dia going downwards. Kalau gravitational acceleration tu positif, semua objek ni dia tak akan jatuh ke bawah, dia akan naik ke atas. So it's not the case lah. Whatever object is dropped from a certain height in this world, it will go down. Bukannya dia naik ke atas. Okay. So gravitational acceleration is negative 9.81 t square. Okay, so this is what we have. So bila kita buang 0 here and we multiply 1/2 with minus 9.81, we will get minus S equals to 5t minus 4.905 t square. Okay, kita boleh solve ataupun kita boleh buat sampai sini saja. We cannot solve anything yet. So now we go to ball B. Okay, ball B. We use the same equation dengan apa yang kita guna dekat atas ini. Okay, the same equation. Alright. So S here will be minus S lah, because what we want is what is the S here. S dekat sini. And starting from this origin. So when ball B arrive at this point, S here will be dikira dari origin masih lagi negative S lah, masih lagi pointing ke bawah. Although ball B is moving up, bila ball B sampai dekat sini, the position ataupun the displacement of ball B ni masih lagi di bawah daripada origin, because kita set the origin dekat sini. So it will still be negative S also. Okay, sama saja. Alright, S naught. Okay, S naught ni, this is why it is important to establish an origin. So kalau tadi S naught equals to 0 because ball A is exactly at the origin. Now ball B is not at the origin. It is 30 meter down ataupun 30 meters below the origin. So what you should write for S naught is minus 30, not 0. Okay, it is different from ball A. Ball A is 0 because it is located exactly at the origin. But for ball B, it is not 0, it is 30 meters below the origin. So it should be minus 30 for S naught untuk ball B. It's minus 30. Okay, V naught is the velocity at which ball B is thrown up. So velocity dia 20 meter per second. So you have 20 T. Okay, 20 T dekat sini. And then dekat belakang ni samalah, 1/2 minus AC is the gravitational acceleration minus 9.81 T square. So when you when you calculate everything, you will get minus S equals to minus 30 plus 20T minus 4.905 T square. Okay, so kita boleh buat sampai sini je. What should we do next? Siapa yang dah jawab tadi? Sukanya.
Yeah.
So what should we do next?
Okay, when the ball A and ball B meet, the S1 and S2, the position will be same, right? So
Okay.
S1 equals to S2.
Okay, good. Okay, let me go to the next one. Okay, so I bring this equation and also this equation from ball A and ball B. So I bring it here. Okay. What Sukanya said is correct. Okay, so basically kalau you tengok on the left hand side, minus S sama dengan ini untuk ball A, minus S sama dengan ini untuk ball B. So both on the left hand side is equal to minus S. Basically you can rewrite this equation into this. 5T minus 4.905T square equal to minus 30 plus 20T minus 4.905T square. Kenapa you boleh write macam ni? Because this portion is equal to minus S. This one is also equals to minus S. So technically, this is equal to this. Betul eh? Do you get what I mean here? Yang lain, yang lain
Yes,
selain
sir.
daripada Sukanya dah jawab. Aizuddin, do you understand what I am saying here?
Yes, sir. I understand.
Okay, good. So sebab left hand side you ada minus S, left hand side for the second equation you ada minus S, so you can write this equals to this. Okay. Bila you write this two, you can solve lah. You tengok dekat sini minus 4.905T square. Yang ni pun minus. So bila you bring this dekat sini, dia akan jadi plus. So minus 4.9 plus 4.9 jadi 0. So T square ni boleh potong. Okay. And then you can do some rearrangement lah. Okay. What you can do is you bring minus 30 dekat sini, dia jadi positif. You bring 5T dekat sebelah kanan, dia jadi 20 minus 5. So dia jadi 15T equals to 30. Okay. So when you solve this, you will get T equals to 2 seconds. T equals to 2 seconds ni yang mana? Apa T equals to 2 seconds ni? T
The
equals
time
to,
when ball A and ball B meets together.
yes. T equals to 2 seconds ni is the time bila ball A sampai sini and bila ball B sampai sini. So dekat sini bila both balls to pass each other, the time is 2 seconds. But that is not what is being asked by the problem. The problem tanya, what is the height from the ground? So, first tadi kita dah dapat time. Time equals to 2 seconds. Now we need to determine what is the height from the ground. So how do we do that?
Substitute the time in either one equation.
Yes, correct. So you substitute the time in this equation lah, in any of these equations. So I have chosen the equation from ball A. So I pilih equation from ball A. So kita dah tahu T here is 2 seconds. So I will substitute the 2 seconds in this. So what we get is, we will get S equals to 9.62. Basically, you will get minus S equals to minus 9.62. Tapi because left hand side ada minus, right hand side ada minus, so minus dua-dua tu akan hilang lah. So what you get is S equals to 9.62. Is this the correct answer, Sukanya?
So I got a different answer because I didn't put the negative sign.
Okay. So anybody else, is this the correct answer?
Sir.
Yeah.
So from the start of the equation, you started from your origin is 30 meters above the ground, kan?
Mm-hmm.
So I did from just the origin as at the floor, and I think the answer is correct, because if you my answer is 20.38.
Okay,
so if you take 30 and minus 9.62, you get my answer.
Yes, okay.
Actually,
Good.
I got the same answer as Mutu, sir.
Okay, so thank you Mutu and Sukanya. So that's why I'm asking, is this the correct answer or not? So mari kita lihat balik the drawing tadi. Okay. What is S yang saya dah calculate here? The S that I have calculated here is this S from the origin of the building going down sampai sini. So ini distance from this distance. But is this what is being asked by the problem? No, the problem tanya what is the height from the ground. Maksudnya dia nak daripada bawah ni sampai ke atas. So what should I do is I should take 30 meter dekat sini, which is the total height ni, minus with the S yang saya dah calculate here. So finally you will get the distance from the ground, which ball A and ball B will meet each other, is 20.38 meter. Betul lah? Ini sama macam jawapan you, Mutu and Sukanya?
Yes, sir.
Okay,
Yes, sir.
good. So the rest of you, do you have any question on this?
No, Doctor.
No, semua boleh faham
Yes.
Okay. Okay, kalau semua dah faham, so that will be all the answers for tutorial number 1. Okay. So I will okay, I want to show you the column page. Okay, can you see the column page now?
Yes.
All right. So in column, basically for week number 1, wait, let me turn off the editing. Okay, so for week number 1, basically I have uploaded the lecture video and also the recording from our session. Okay, yang lecture video ni from my previous semester, but this is what we have discussed in the class last week. So I have uploaded it also in Kalam, so you can watch if you want. And then all the lecture notes and tutorial, and every week I will put in the feedback. So if any of you have feedback, you think that you don't understand or I should improve my method of teaching, for example, you can write in here. It is not compulsory, bukannya mesti you isi. If you want to fill in, if you have any suggestion to improve the lecture, you can write in here. For every week, and nanti week 2 I will also put this feedback form in here in week number 2. So week 2, I have uploaded the lecture video for erratic motion for you to watch. I asked you to watch yesterday. Maybe some of you have not watched, so I want you to watch after this. Okay, and then I have also uploaded the tutorial 2 for erratic motion, which we will discuss on Wednesday. And after Wednesday's class, I have also uploaded the curvilinear motion. You can watch this video also before Wednesday's class or after Wednesday's class. During class on Wednesday, we will discuss the tutorial number 2, and maybe I will go a little bit into the curvilinear motion. Okay, so please always log into Kalam so that you can get all the informations lah in Kalam. All right. So now, before I proceed, I want you to fill in the attendance for today. I will share the link in the chat box. Okay, I have shared the link in chat box. It's a Google form. So please visit the Google form and key in your attendance now. Okay, everybody has key in the attendance. Okay, so basically, what I want to do next is the same as what I have uploaded in the video lah. So let me share the slides for erratic motion. I will just do some brief introduction about erratic motion, but the detailed explanation you can watch in the video, and if you have any question, you can ask me on the next class. Okay, so macam saya dah explain sebelum ini, continuous motion itu ialah throughout the motion, moving from point A to point B, for example, from beginning until the end, the motion, the character of the motion of the object is the same. But then in erratic motion, in erratic motion, the position, velocity, and acceleration cannot be described by a single continuous mathematical function. Okay, maksudnya kita tak boleh buat macam tadi dalam tutorial tadi, V is equal to 2t square, for example. So that is not the case for erratic motion, but instead we have a series of function ataupun dikenali sebagai piecewise function. Piecewise function ni macam mana? Macam ni. It is written in this way. Okay, A sama dengan, lepas tu kita ada macam the curly bracket here, 0.4t for t equal or larger than 0 until t is smaller or larger than 10. So maksudnya 0 sampai 10 seconds, A is 0.4t. When t is 10 until 20, A is 2.4. When t is 20 until 30, A is 0. Okay, so because of this nature, because of the multiple function ini, throughout the motion tu ada multiple phases, it is more convenient to represent the motion in form of graph. Okay, so basically in erratic motion, you will be drawing the graph of the motion. Kalau macam tadi kita lukis graph satu graph saja, but this in this case it will be graph based on the phase lah, based on different phases. Okay, I will show you very quickly graph for the acceleration, and then you can watch the rest of the video where I explain how to calculate how to draw the graph for velocity and displacement in the video that I have uploaded. Okay, so first we draw the axis of the graph lah. The time x-axis will be the time. Okay, 0 to 10, 10 to 20, 20 to 30. And then you have the y-axis for the acceleration. Okay, so from 0 to 10 seconds, we know that 0.4 t here is a linear graph lah. It's a linear function. Okay, so what you can do is you pick 0, the first the lower limit of the duration of the phase. You key in here. So when t equals to 0, a equals to 0.4 times 0. So it will be 0. When t equals to 10, you key in 10 in here, you will get a equals to 4. So masa time sama dengan 10 seconds, acceleration is 4. So masa time sama dengan 0, acceleration is 0. So you have 2 points. Basically 1 point down here, 1 point here at a equals to 4. So what you can do is draw a straight line, because you know that this is a linear relationship. A linear relationship. So from 0, 0 to 10, 4. Okay, 10 is the x-axis, 4 is the y-axis. Okay, now let's go to the second part. T is 10 until 20. So A is 2.4. So this will be just a straight line. Here 2.4 is roughly about here, 2.4. Daripada 10 hingga 20, acceleration is constant, 2.4. So this is what you get. You can draw the connecting line here from phase 1 to phase number 2. And then the last phase, 20 to 30, acceleration is 0. So this is another straight line down here. A is equal to 0. Okay, so this completes the acceleration time graph. So basically in erratic motion, you have acceleration time graph, you have velocity time graph, and then displacement time graph, ST. And then we can also draw the acceleration displacement graph, AS, and also the velocity displacement graph, VS. So I have shown all the examples in the videos that I have uploaded in Kalam. Okay, so I think I want to end the class now. I will give you time to watch the video. The videos I think is not very long. Let me see how long is the videos for erratic motion. It's about 1 hour, but still you can skip all the parts because I have the chapters. I have set all the chapters in the videos. So do you have any question before we end the class for today? Ada apa-apa soalan?
No, Doctor.
Okay, so basically to summarize, we have learned about continuous motion in the first week, and we have done a few tutorials. And then for week number 2 today, I have given you a brief introduction about erratic motion, and also I have uploaded the videos for you to watch the detailed explanation about erratic motion, and you should watch the video after this. Okay, and then in Kalam also I have put the tutorial number 2 about erratic motion, so you should do that tutorial before coming to class on Wednesday. In the class on Wednesday, we will discuss tutorial number 2, and then we will go into curvilinear motion. Okay, sekarang ni whatever that we have been discussing now is rectilinear motion. Rectilinear motion means the motion is in straight line. Okay. On Wednesday, we will go into curvilinear motion, where the motion is no longer in straight line, but it is moving in a curve path. Okay, the path of the motion, or the trajectory of the motion is a curve. So itu kita punya next subtopic. Alright. So if you don't have any question, this will be the end of the class. Any more question from you before I end the session for today?
No, sir.
Tak ada question, eh? Okay. So good, thank you. Again, I would like to thank all of you for coming to the class today. And I will see you again on Wednesday, same time, 10 a.m. And please remember to watch the video on erratic motion and do the tutorial. And if you have time, please watch the videos on curvilinear motion also. I will explain the curvilinear motion on Wednesday. Okay, so again, thank you. Assalamualaikum and good morning.
Thank you.
Thank you, sir.
Waalaikumsalam.
Thank you, sir.
Thank you,
sir.
sir.
Thank you, sir.
Thank you, sir.
You're welcome.
Thank you, sir.